Hello, Algebra 2. This is the third video for Desmo's slide number 3 for help. So let's get started. So on slide 3, you're going to be matching graphs to their equation. Here's an example. So you need to check for even and odd and behavior. So if you have both arrows pointing up, then you have an, hold on a minute. Then you have an even because both arrows are up. So your equation would be something with x squared, x to the fourth, x to the sixth. How many x's you have total? All right, so your degree would be an even number. Check for your leading coefficient. Is it positive or negative? In this case, it's positive because both arrows are pointing up. So it would be a positive leading coefficient. So right away, if you look at your answer choices, it cannot be letter B because it has a negative leading coefficient. So forget B, it can't be that. And then go ahead and write out all the x-intercepts that are on the graph. So write out all the x-intercepts. So right here we have an x-intercept at -3. We have another one at 2, and we have another one at 5. So then you also need to check for double roots. Yes, we have one. It's right here. So this is a double root. You know that because the graph comes up, hits the x-axis, and bounces back down. So the double root is when you bounce, your graph bounces. So when you have a double root, that means you're going to have parentheses with a square. It means you're going to have this exponent when you have your parenthesis. That's what it means. Okay. So we're going to have a double root at 2. So all the x-intercepts, one at -3. So when we put that in the equation, we write it opposite. So for this -3 x-intercept, we put it back into the parenthesis opposite. So when we do the one with the 2, it'll be x -2 because we have a positive 2. So you take it opposite. It's also a double root. So we need an exponent. And then for the last one, it's a +5, so it goes back in opposite, -5. Okay, so the answer is going to be C. So remember, what you see on the graph, you put back into the parentheses as opposite. All right? Okay, so let me show you what I did for the slide number 3. So I organized these cards. These ones on the top have a positive leading coefficient. They start with positives. And then you can see here, these all have negatives in the front. So those are all negative leading coefficients. So these ones I've grouped together. These have negative lead coefficients. And what does that mean for the graphs? Why did I do that? Well, if you look how I organized my graphs and look at the arrows, let me just change colors really quick. So these arrows both point down, so that means it's going to be a negative leading coefficient. This graph too, also. And then these graphs, where there's one arrow up and one arrow down, you only look at the right side, and the right arrows all point down. So all of these graphs have a negative leading coefficient. So that's why I grouped those together, because both arrows are down or the right side arrow is down. And then this is just the opposite over here on the other side. If you look at the arrows, both arrows up, both arrows up, both arrows up. And this side is right arrow up, because remember, it's only the right side arrow that matters. So when we have these graphs, then we know it's a positive leading coefficient. So if you could organize yours in a manner like this, Doesn't have to be exact, but that's the best way to get started. You can hit pause here. Please hit pause. Okay, so you should be back. So I just wanted to show you, you're going to have to match up numbers. I wanted to show you one thing, that you can make the graphs bigger by tapping on them. If you tap on the graph gets bigger, and you can see these numbers easier. I just picked a random graph. So this is at -2, this is at 0, and this one's at +2. So that you can see those numbers better, you can click on the graph and then close it by hitting the X, okay? Just so you know. Now, I'm going to choose a graph to work with. So I think I picked this one. It'll show up on another slide. So I'm going to work with this graph right here. And since both arrows are down, I also made a copy of all of these graphs because they all have lead negatives. So that means both arrows are down. So I'm going to switch slides and just work with this highlighted yellow graph and the highlighted equations. And that's right here. So here's the graph I was talking about. So I blew it up so that I could, I tapped on it so it would get bigger. And then I'm going to go ahead. This is my pen works. And I'm going to note where my intercepts are at. And this one you have to be careful on. This one is at number 1. So you have to count out your graph. So it's at 1, it's at 0, and it's at -2. Okay? There's a double root at 0. So that means it's going to have x with an exponent. So when I look for the graph, remember you're looking for opposites. So for this one, I need x plus 2 because you need opposites. For this one, I need x with an exponent. And for this one, I need x minus 1 because it's a positive 1 on the graph, but we need the opposites, right? So the arrows are both pointing down, so I have all the lead negatives I need. Which one has x plus 2 and x minus 1 and x squared? There we go. That's our equation, and we based it off of writing these from the intercepts but opposites. The 0, 1 will have the exponent. The 1 has to go in at -1. So this is our answer. Okay, so you're matching up the numbers for the exponent, or the numbers for the x-intercepts. Just remember you take the opposite numbers, okay? All right, good luck. Thank you. This was the last slide. Make sure that you email Miss Artofer and Miss Fairbanks when you think you have all the slides done and accurate, and we'll let you know if they're all correctly matched up, and then you'll receive your points. So if you're doing this late, make sure that you email Miss Artofer and Miss Fairbanks to recheck your answers on Desmos. Thank you.